Hello everyone, this is B Pawan, bearing of roll number 20955 A0411, and I belongs to Electronics and Communication Engineering branch, and my AIT concept video topic for vlsi design is the operation of NMOS depletion MOSFET. Let us go through about the topic briefly. First, we have to know what are depletion mode MOSFETs. The metal oxide semiconductors The metal oxide semiconductors field effect transistor or MOSFET is of much greater commercial importance than the junction FET, that is JFET. MOSFETs are three terminal devices with many functions covering signal amplification to digital applications such as logic gates and registers or memory errors. The PN junction diode is a most basic two-terminal semiconductor device. A MOSFET is a three-terminal semiconductor device. Three-terminal devices are more functional than two-terminal ones because they have numerous applications. The basic principle involved in three-terminal device is to control the current flowing in one terminal by varying the voltage between the other two. Depletion mode devices have an open channel for free carriers to flow between drain and source. Applying a voltage with the proper polarity between gate and source, the carriers in the channel are essentially depleted. When the channel between source and drain squeezes or pinches off, it rejects additional free carriers to flow through it. The gate to source voltage VGS regulates the point at which the current between the drain and the source is pinched off. Increasing VGS in the negative direction in N-channel devices closes the drain source channel. The same is true increasing VGS in the positive direction for P-channel devices. The depletion mode MOSFET has characteristics analogous to a JFET between cutoff and IDSS saturation. It also has the added feature of operation into the region of positive polarity for VGS enhancement mode. The depletion mode MOSFET, however, is relatively rare device and is not commonly used. And is not commonly used. Configuration of N-channel depletion mode MOSFET NMOS. Two heavily doped wells of N-type silicon are formed in a slab of P-type material molded from a silicon base referred to as a substrate. It is the device foundation. The heavily doped N-type section act as the source and drain. Interchanging the source and drain terminals does not alter the MOSFET characteristics. It is a symmetrical device. A very shallow channel of lightly doped N-type material lying on the surface of the silicon connects these wells. The channels has the same type of impurity as used for the source and drain. Over the structure's surface, there is a layer of insulating silicon dioxide with holes that allow connection with the source and drain terminals through metallic contacts. SiO2 is an insulating layer referred to as a dielectric.
changing at very rapid pace. Technology is continually
The
being updated
metal electrode
and older technologies
deposited
patched
on
up.
the oxide over the channel
Uses
serves as the
network support,
gate for the
personal
transistor. The gate
Bluetooth
is insulated
environment
from the
adapted
N channel by
technologies
the SiO2
accelerate
layer.
their places
There is
uses
no electrical connection between the
88 network
N
tags,
channel and the gate
multi-layer
terminal.
network, building
A very
backbone,
high
campus
input
network,
impedance is
network
an
within
essential
rural network,
property of the
wide
MOSFET,
area network,
resulting
enterprises,
from the presence of
networks users
SiO2
in a
layer.
department, company or
Then
work group
the
to
gate current
manage
Ig is essentially 0 amps
plans
for
together
DC
in a buildings.
biased designs.
ADM,
In
FDDI,
combination with the
fast Ethernet,
semiconductor channel
gigabyte,
and the insulating dielectric oxide layer, the
connects
gate's
building
metal area shapes
plans together.
a parallel plate capacitor
ATM,
with the oxide layer
FDDI,
working as
fast
the
Ethernet,
capacitor
gigabit
dielectric.
Ethernet,
Sometimes
used to
the p-type
network
substrate
sites in a large
also
scale.
has a metal contact
FDDI,
converting
ATM,
the MOSFET into a four-terminal device, the source S, the drain D,
is the
the
example
gate
of
G,
metropolitan
and the substrate B. But the
wide area
substrate is
networks
typically lightly doped and it's
designed
not an
to
effective
connect
gate. The custom
geographical
is connecting
distant
the
network
substrate
sites
to the
together.
source terminal internally.
Although they could
Another
be
designation for the
sensitive or
substrate is
stable,
the body.
often through a
NMOS
service
with gate to
provider,
source voltage VGS is
SWTC,
equal to 0,
SPRT,
making the gate to source voltage
ATM,
VGS equal to 0 and
is either
applying a
a
drain to
VLC
source
line
voltage
or
VDS
switches circuit
and
technology.
appreciable drain current IDS
Connects routers
may flow between drain and source. This effect results from the positive charge at the drain attracting the free electrons of the N channel. This current is analogous to the one flowing in JFET's channel. IDSS is the drain saturation current flowing when VGS equal to 0 and VDS is large enough to produce pinch off. NMOS with a gate to source voltage VGS less than 0. Applying a gate to source voltage in such a way that will make the gate negative charge to the source. The negative charge will force free electrons out of the channel. It will induce positive charges in the channel through the SiO2 of the gate capacitor, forming a carrier depletion region in the silicon surface at the oxide silicon interface. Since the current is due to majority carriers electrons for an n-type material, the induced positive charge makes the channel less conductive, increasing its resistance.
The end station, the application that run on the end station, the network which support
The
traffic
redistribution of charge in the channel, causing an effective depletion of majority carriers, accounts for the designation of depletion MOSFET. By making the gate negative enough,
operating systems,
the depletion region will extend entirely across the channel,
networks,
joining the depletion region at the PN junction on the other side of the channel. Under this condition, the channel cannot carry current between drain and source. This occurrence is comparable to that of pinch off occurring in a JFET at the drain end of the channel. The pinch off voltage is the negative gate value at which the channel becomes non-conductive, usually a few volts.
topologies use shared media access control protocol. Ethernet, CMS, CD, carriers and multiple access
This occurrence is comparable
attention. 10
to
Mbps,
that of
100
pinch
Mbps,
off
1
occurring
Gbps.
in a JFET
MAC,
at the
media
drain end of
access
the
control.
channel.
4 Mbps,
The
16
pinch off
Mbps.
voltage is the
DTA,
negative
SMT, station
negative
map,
gate value
100
at
Mbps.
which the channel becomes non-conductive, usually a few volts.
Uses TCP as the common transport protocol developed out of the US government. APRENPT supports access around the world to both public
NMOS with gate to source
private
voltage
users.
VGS greater than 0 A depletion mode MOSFET also works in enhancement mode. The NMOS can operate in a positive to gate source, applying a gate to source that will make the gate positive. Extending the drain characteristics to high values of VDS will encounter a breakdown region where the drain current is